physics homework book for BTEC Unit 1 and stationary waves. So you did these with, you might have done these with slinkies or elastic bands, and what we've got here is the fixed string like a guitar, and we can see where the string is fixed at the ends. Those are called nodes. Anywhere where the wave is in the same position as the fixed ends, that equilibrium line, then that's also a node. And then where it looks like a peak or a trough, those are antinodes. And these are stationary waves where we're getting some sort of oscillation and reflection of the wave, and when those two match up we get a stationary wave. And you need to be able to label nodes and antinodes. So for example, on here we always have the nodes at the ends of a fixed string, on one end of the guitar and the other. So anywhere where these are in the middle we can call those nodes. And one interesting thing to see here is that as we're moving from the first, second, third, fourth harmonic, as we increase the number of harmonics, the number of nodes increases. So we've got, if I just write N for node up there, you can see we've got 2 nodes, 3 nodes, 4 nodes, 5 nodes. If we were doing the 5th harmonic, we'd just stick another node on. And we can label these as antinodes, antinodes, and so on. So anywhere where we are a sort of peak or a trough, we are getting antinodes, and you do get bored of writing these on. Okay, so for this 4th harmonic we've got 1, 2, 3, 4, 5 nodes in total. Task: draw the 5th harmonic. Here we go. So it's our fixed string with a node at each end. And what did we say? So currently we've got 1, 2, 3, 4, 5 nodes, 3 in the middle. So I'm going to have 4 in the middle. 4 nodes in the middle. 1, 2, 3, 4. And I'm going to draw a wave. It's got to start at the node and end at the node. Can't end at an antinode. And it's going to go back to the node, so it's going to go up, down, always going through the node. And then you've got the other position it is in, because this is oscillating. And you can write on antinode, 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 antinode. There we are. So we've followed the question, 5th harmonic, labelled the nodes and antinodes. Challenge question. Stretched wire of length 0.8 meters vibrates at its first harmonic with a frequency of 256 Hz. What's the wavelength? Right, information it gives us. Calculate the wavelength. Well, it gives us a length, so it gives us this 0.8, and we need to go, right, what's the wavelength in relation to that? It says first harmonic. So there's the first harmonic, and if you look at the red line there, you go, is that a full wavelength? And the answer is no. Look, only in the 2nd harmonic where it goes down, up and back round to the same position again, that's a full wavelength. So the first harmonic is actually half a wavelength. So on this diagram that's half a wavelength, that's 1 full wavelength. the next one is 1.5 and then 2 wavelengths. So calculate the wavelength. So if we say first harmonic is half a wavelength, and we've got half a wavelength, so half a wavelength equals 0.8 meters, then I think we just need to times that by 2. So a wavelength equals 0.8 times by 2 equals 1.6 meters. And then we are calculating the speed of the waves on the wire. So back to our normal equation. So V equals F lambda. And again, I'm just going to write these out on the right just to get in the good practice of doing equations. So V, we don't know, that's going to be in meters per second. Frequency, it gives us 256 Hertz, and lambda, well, we just calculated that as 1.6 meters. If you do that, then you notice whether any of them are in the wrong units, and it makes it easier to put them into your equation. So get into the practice of doing that. So here we go, F256 times by 1.6, and we need to put that into our calculator. 256 times by 1.6 equals 409.6. 409.6. And what precision should we use to give our answer? We've got 2 significant figures there, and we've got 3 significant figures there. So let's give that to 3 significant figures. So 4. So we're going to have to round that up, but that's 9, so it's going to carry over. So 410, and make sure our units are right, meters per second. And then we're on to some more theory.